In this video, we're going to be learning about the nomenclature of alcohols and thiols, which will add new suffixes to your vocabulary. So, when we named our alkanes and alkenes and alkynes in the last chapter, we learned that we needed to find the longest carbon chain. Now, when we're naming these molecules that have other functional groups, we have to make the longest chain that includes the carbon where that functional group is. Let's take this molecule for example. We can make a chain that's 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons long. The longest chain has 9 carbons, but where is the functional group? The functional group is here. So that means that we have to include this carbon. That means that we will not be using this 9 carbon long chain in our name. We have to have this carbon in our longest chain. So what's the longest chain that includes that carbon? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Our longest chain actually goes down like this. So make sure you look in all directions and you don't just look from left to right. So 8 carbons long would be octane, because there are 8 carbons and they're all single bonded. Now we have to erase this last E at the end and replace it with an "-ol" suffix. So that's octanol. Where is the alcohol located? The alcohol is located closest to this carbon end. We have to look to which chain end is it closest to. So that's going to be carbon number 1, and that's going to be carbon number 2. So the alcohol is located on the second carbon. Now, let's see. We have to include our other branches. So we have this branch, which is 1, 2, 3, 4 carbons long. So that will be butyl off of the third carbon. And we have this branch, which is 3 carbons long. That's propyl. And that's off of the fourth carbon. 1, 2, 3, 4. So now we have to alphabetize them. The B will come first before the propyl. It's hard to budget space sometimes. Here's a practice problem for you. Go ahead and pause this video and try to name this alcohol. Unpause the video when you're ready to check your work. Okay, so the longest carbon chain that includes the carbon chain has to include this carbon right here. So the longest chain is straight across. And that's 5 carbons long. So that is pentane. Since it's an alcohol, we're going to erase the last E and name it pentanol. Now we have that it's closest to this end. So this must be carbon number 1, and that's carbon number 2. So that's 2 pentanol, 3, 4, 5. And so this is a methyl. 1 carbon long, and it's off of the fourth carbon. 4-methyl 2-pentanol. We can also have cyclic alkanes, and so it's no surprise that we can have cycloalkanols. It's a tongue twister. So these are cyclic, they're not aromatic, and so we can see that there's 2 different substituents on this hexagon ring. So the hexagon is going to be our parent, and so it's going to be like cyclohexane, but we erase the E and replace it with all. By default, the OH is off of carbon number 1. So this alcohol is off of carbon number 1. Therefore, we don't have to write that there's a 1 there, because that's kind of like defined to be number 1. So that's why there's not a 1 in this name. Then we minimize in the direction that will minimize the number of this carbon, where the other substituent is. So that's faster to go around this way. They're closer together that way. So that must be carbon number 3, and that's a methyl group off of the 3rd carbon. This is a 5-carbon ring, and so that's cyclopentanol. That must be carbon number 1 because that's where the OH is attached. And then that must be carbon number 2 because if we numbered around the other direction, it would be a much higher number. So that is a ethyl group off of the 2nd carbon. Here's some practice problems for you. Go ahead and pause the video and try to name these. Unpause the video when you're ready to check your work. Okay, so let's do the first one. The first one is propanol. And so prop means 3. Ane means single bonds. And then this one tells us where the alcohol is. So let's go ahead and sketch that. So 3 carbons. And then an OH group off of the first one. Now we have 2,2-dimethyl. So both of those are off of the second one. So it's 2 methyls each off of the second carbon. Now that we kind of have our outline, we can go in and fill in the missing hydrogens. This one must need 3 hydrogens in order to have 4 bonds total. This carbon in the middle already has 1, 2, 3, 4 bonds, so it won't need any more. And this one has 2 bonds coming out of it, and so it's going to need 2 more hydrogens in order to have 4 total bonds. When we name this molecule, this is our parent chain right here. And so that is cyclohexane. Whenever you see a ring, you should make that your parent chain somehow. So that's cyclohexane. Then we erase the E and name that all, cyclohexanol. Now we have 1, 2, 3 carbons off of it. That's propyl. 1, 2, and then 3. And then that must be number 1, 2, 3, 4. So it's off of the 4th one. So this molecule is 4-propyl cyclohexanol. Naming thiols is very similar to naming alcohols. You have to name the parent chain, and that parent chain has to include the thiol. The suffix for a thiol is just thiol. And you do keep the E for this. You don't delete the E. It's a little weird thing that you have to get used to. And then we do number the chain so that the SH is the lowest. So here's 2 molecules. This one has 1 carbon, so you can see here that we keep the E. I think that's because the TH starts with a consonant, and so you kind of need to break up the consonants with a vowel. I think it's more for pronunciation purposes, but whatever. Here you can see that we have 3 carbons, and so that's propane. The thiol is off of the first one, so that is 1 propane thiol. We don't need a 1 here because there's literally only 1 carbon, so it's not like there's options about where to put the thiol. Here, the thiol could have been off of the middle one. And then this would have been 2 propane thiol. Here's some practice for you. Go ahead and pause the video in order to work out these practice problems. Unpause the video when you're ready to continue. Okay, let's go over this. So for our first one, we know that this carbon must be included in the longest chain, because that's the one that the thiol is attached to. So let's see. I can go 1, 2, 3. Even if I went down for the third carbon, that's okay too. The substituent would still be off of the same carbon number. So there's 3 carbons in the longest chain. So that's propane, thiol. I can use my imagination to picture that the thiol group could have also been elsewhere, could have also been off this middle carbon. And so I'm going to have to put a number, and that's going to be a number 1. So those 3 carbons are accounted for. Now I need to account for this one. That is, if this is carbon number 1, that's going to have to be carbon number 2. And so we are starting numbering from this end because that's where the thiol is. And so this is carbon number 2. That's 2-methyl 1-propane thiol. Now this problem says to draw the condensed structural formula for 2-butane thiol. When it doesn't specify what type of structural drawing the question's asking for, then you can do your choice. But if it does specify what type of structural drawing to do, then you need to do that, otherwise it's going to look like you don't know what you're doing. So we know that condensed structural formulas outline where the carbons are, and they won't expand out the hydrogens. But we can just like leave a little bit of space to insert our hydrogens once we have kind of an outline going. So you can see I left some blank space here for the hydrogens. And now we have a thiol group off of the second carbon. So if I make this one a number 1, then this would be where the thiol group is. This first carbon will need 3 hydrogens in order to have 4 total bonds. This carbon has 1, 2, 3 bonds coming out of it, so it's only going to need 1 more to have 4 bonds. This carbon is going to need 2 more hydrogens in order to have 4 bonds, and then this last one is going to need 3.